Let's examine how we can use the graphing calculator to help us in section 2.4. So remember here we're trying to solve absolute value equations and inequalities and also find the absolute value of a function. So we did some problems earlier where we had to solve it by hand, like to solve this inequality analytically. Let's take a look at how we can use the graphing calculator to help us to solve that. There's a couple ways you can do this. You could look in y1 and input the absolute value of 2x plus 5, and then in y2 input the right hand side of the inequality and graph and look at the relationship of the graphs. Now remember, we would have solved for the equation by hand, or you could use the intersection of graphs or the zero, I suppose, if you wanted to do that. But let's just recall we had what? 2x plus 5 is equal to negative 13, or 2x plus 5 is equal to 13. So quickly here we found that 2x was negative 18, so x is negative 9. Or if we subtract 5 from 13, we get 2x equals 8, so x was 4. So we had as our solutions negative 9 and 4. So whenever we input on the calculator, remember to do absolute value. We have to press the math key and go over to the number menu and select option 1 of 2x plus 5. And close parentheses and enter. And then we're going to put y2, which is 13. Now let's see if I'm in the standard window. I am. We have a problem though, and what is the problem? What does y equals 13 look like? Yes, that's exactly right. It is a horizontal line through y equals 13. So to see that, we have to extend our window vertically. And so instead of having a y max of 10, perhaps we have a y max of 15, 20, we'll put in 20. And let's use a y scale of 2 just so we're not too cluttered and see how that looks. Yeah, perfect. Now if you want to extend it some to the left so you can see the relationship between the two graphs a little bit better, we can. Instead of having an x min of negative 10, perhaps we have an x min of negative 20. And let's change the scale there to 2 also. Yeah, so that gives us a better picture of what we're looking at. So we know that where they intersect one another is where they are equal. What we are trying to find is where is the absolute value below the horizontal line. And that happens in this region here, right? Let me take a picture of this for just a minute. Oops, didn't mean to do that. Let me erase that. Okay. So we know that what we're trying to find is where is that graph less than or equal to 13. That occurs in this middle region here. But remember, we're answering with our x values. What x values are designated by that? And that value was between the negative 9 and the 4. So the region of our number line would be between negative 9 and 4. Okay? Now here's a problem that's similar to that. Absolute value of 4y minus 9 is greater than 14. Let me just show you an alternate way you could do this. An alternate way is we could put in to y1 absolute value of 4y minus 9 minus 14, and there we're trying to find there where the absolute value of 4y minus 9 minus 14 is greater than 0. So this is where the graph would lie above the x-axis. So you see there's various ways to do this. Now again, we would have had to solve something by hand. We would have found where 4y minus 9 is equal to negative 14 and where 4y minus 9 is equal to positive 14 to get what was that, negative 5/4 and 23/4. Okay, so now if we graph, let's say this, clear this out. So in y1 we're going to put absolute value, so press the math key go to the number menu, select option 1, absolute value of 4y, but for our variable we will use x, 4x minus 9. Very important to close parentheses, and then minus 14, and now graph. Okay. Now if you want to go to the standard graph, standard window, we'll do zoom in 6 to see if we can see everything there. Okay. Doesn't really matter. That's going down to V and coming back up. The main thing is, since we recentered this or related it to 0, the key thing here is our x-axis. Let me move this down just a little bit there. Okay. So what are we looking at? We're trying to find where this expression is greater than 0, or where it is above the x-axis, and that happens in the outermost regions. And so what were our boundary numbers? They were -5/4 and 23/4. So it would be beyond the 23/4 and to the left of the -5/4. So it just is a way to confirm which region we're looking at. In fact, if you know the boundary numbers, that is, you know the solutions to that associated equation, you don't even have to plug in and test or use the compound inequality. You can graph and look at the relationship between those two problems or two graphs. Now, there's another way. You can actually enter the whole entire inequality in one. Do you remember doing that? If we were trying to find where absolute value of 4y minus 9 is greater than 14, we could say absolute value of 4x minus 9 is greater than 14. Now to do that, to get the greater sign, you'd have to do second math to go to the test menu and select option 3. And now graph. And remember what that does for you. That tells you exactly what regions of the number line contain solutions. Okay? Now, we also can do this problem graphically, where we have absolute value of 9x plus 5 is equal to 0. We did that where we found that the absolute value of 9x plus 5 equals 0 only has one solution. So let me enter that. I don't have to really enter equals 0, because what is that? That is the x-axis. So I'm trying to find, where does that touch the x-axis? Well, that touches in one point, and that was where that 9x plus 5 was equal to 0, which is at -5/9. Well, then graphically we can see, where is it greater than 0? Well, it's greater than 0 everywhere, right, except for where it touches 0. So that is to the left of the -5/9 and to the right of -5/9. So that just confirms that our solution for part B is -infinity to -5/9 union -5/9 to infinity. Part C, where is that expression less than 0? To be less than 0 means that the graph would have to be contained below the x-axis. And the graph is nowhere below the x-axis, so part C is the empty set. Okay. The next problem, how to find out where pi x plus 8 in absolute value is equal to -9. Well, here again we could use the graphing calculator. In y1 we could enter absolute value of pi x plus 8, and in y2 we could enter -9 and see where they intersect. So press math, go to number, and select option 1. To get my pi symbol, notice that it is above this caret symbol, so I can do second and the exponent key, x plus 8, close parentheses, enter, and that's equal to the -9. Now graph. If there's a solution, those two graphs would intersect, but they never intersect, which means that there is no solution to that equation. Now, where is the solution for part B? Part B says where absolute value of pi x plus 8 is less than -9. Well, that would mean that that V-shaped graph has to be below this horizontal line, but that is never the case, so that tells me that that would also be the empty set. Now, part C says, where is the absolute value of pi x plus 8? Where is that V-shaped graph above the horizontal line? What's above it? Everywhere. So that tells me the solution is all real numbers. Okay. Now you can also confirm on the table, if I'm comparing the values of y1 and y2, I'm trying to find where is, in this case, where's y1 larger than y2? Well, y1 is larger than y2 at every value of x. So that would tell me it's negative infinity to infinity. Where is y1 less than y2? Nowhere, right? None of these positive values are ever going to be less than a negative. Where is it equal to negative 9? Again, that's never going to happen. So your table is a pretty handy trick or tool to use to help you see and visualize the solutions as well. Okay. Now, to solve this, part A was analytically and part B was to use graphing calculator. So if I wanted to, in part A, to solve it by hand, which we did earlier, we had to set 2x plus 1 equal to x minus 3, and also 2x plus 1 equal to the opposite of x minus 3. And I know it'd be really handy if one of you could tell me what those solutions were, so I won't have to work it out again, but let's do that. 2x, I can subtract x to get x is equal to negative 4. And on the other side, we get 2x plus 1 equals the opposite of x plus 3. Adding x gives me 3x is equal to, subtract 1, 2, so x is 2/3. Okay. So I know those two are going to intersect at negative 4 and 2/3. How can I find the solution for the inequality? Couple ways. You could set the 2 or enter the 2 into y1 and y2 and compare the relationship, or you can kind of use the x-intercept method, which might be a little bit easier here because sometimes comparing the two V-shaped graphs can be kind of tricky. So in part B, if you enter absolute value of 2x plus 1 minus the absolute value of x minus 3, we're trying to find where that is greater than 0. So what we could do is enter absolute value of 2x plus 1, close parentheses, minus the absolute value of x minus 3, and graph. Now, intersection point should be the negative 4 and 2/3. Oops. So at negative 4 and 2/3, we have our intersection points, or our zeros. Now where is it greater than 0 means where it is above the x-axis. And where does that happen? Well, that happens to the right of 2/3 and to the left of negative 4. So our answer would be from 2/3 to infinity. Oops, I should have done my other piece. Negative infinity to negative 4, union the 2/3 to infinity. And where is it less than 0? Right, part C would be where that's less than 0, and that would be between the negative 4 and 2/3. Now solve the following graphically. Probably what I would do in part A is enter absolute value of 3x plus 9 plus absolute value of x plus 3 minus 12 equals 0. So I'm going to enter this whole thing in y1 and then use the 0 function to find my solutions. So to have absolute value of 3x plus 9, close parentheses, plus the absolute value of x plus 3 minus 12, and graph. Everybody get that? So absolute value of 3x plus 9 plus the absolute value of x plus 3 minus 12. Now to solve the equation, I'm setting it to 0 and going to use my x-intercepts or my zeros to find the solution. Now graph. Okay, so there are indeed two solutions. One looks to be 0 and the other one looks to be like -1, -2, -3, -4, -5, -6. It looks like our solutions are 0 and -6. How can we be sure? Well, we can do second and trace and choose option 2, which is the 0 function. Now we have to choose which one we're going to do. Since we have two of them, we're going to have to repeat this process. If we find this 0, we will have to do a left bound and then a right bound and then a guess. Yep, so that 0 is x equals 0. Now to do the other one, press second, trace, and 0 again. Now we've got to do a left bound of this problem. So let's say like -8. Okay, and then a right bound would be like -5. And our guess is -6. Yep, and exactly. We see that 0 and -6 are the exact numbers that we need for the solutions. Now, we can use this graph to find out the solutions to the other part, right? If I'm now, instead of saying where it's equal to 0, but now say where it's greater than 0 in part B, so where that whole expression is greater than 0, well, where is it greater than 0? Where it's above the x-axis, right? And that is to the right of 0 and to the left of -6. So it would be from -infinity to -6 union 0 to infinity. Now why am I putting parentheses on 0 and -6? Yeah, that's exactly right. There is no equality there. I have to include where it's strictly greater than 0, not where it is equal. So what would then be the solution for part C? Well, part C is everywhere else, right? Where it's less than 0 would be between the -6 and 0. Okay? Now, our last problem here is to solve graphically where absolute value of 2x plus 1 is equal to 6x minus 15. Well, hopefully no surprises here. You can enter absolute value of 2x plus 1 and enter. Now notice the right side is just a linear expression. There's no absolute value, so 6x minus 15. And enter. And graph. Okay. So we have a solution point. You might want to extend the graph vertically some so you can see that a little clearer. Let's change our window setting. Instead of having a y-max of 10, maybe let's have a y-max of 15. Yeah, so we can see that a little bit better. So what is our solution? We can find our intersection by doing second, trace, and this time use the intersection of graphs, which would be number 5. Now first curve is our absolute value, second curve is our linear, and guess we can move to that point and press enter. So look, it says the intersection is 4, 9. So what does that tell us about the solution for that equation? The solution is only the x value, so the solution is 4. Okay, so that was where I entered y1 to be absolute value of 2x plus 1, and y2 was 6x minus 15, and then we found the intersection of their graphs. Okay, so that concludes this lesson. If you have any problems with the calculator, don't hesitate to contact me. Thanks so much.